All right, yay, let's greet each other properly, everybody. This is Mr. Aynesworth here at Great Oak High School in 2024. Let's get on it. This is your first mastery on the unit circle. And as stated at the very top here, you want to try to achieve this and complete the entire thing in under 7 minutes. All right, it goes in the test category. And each mastery, or this mastery, is achieved when you complete everything under 7 minutes with less than 3 errors. All right, so just read the directions there. And you may attempt this as many times as needed. But if you do additional attempts, if you don't pass the first time, well, you got to see me outside of class, as stated up top in the directiones. All right. Now I'm going to be teaching a little bit as I do this, so I'm not going to be doing this at my speed. But here we go, and I'm going to be kind of just going through it, just in case you need it, right? Okay, so here we go. The first thing we need to do is get the special right triangles going. 30, 60, 90. You have to put the angles in. You have to know what it looks like, what the angles are. And the hypotenuse is 2. Opposite of the 30-degree angle is half of that, so it's 1. And then the opposite of the 60 is rad 3. For the 45, 45, 90. Okay, because the side lengths are the same, because the angles are the same, it's isosceles, which means it has 2 congruent sides. It's half of a square. And if they're both 1, the hypotenuse is rad 2. The other one's called a scalene because all 3 sides are different length sides. Okay, the next one's isosceles. All right, after you get that, then you can complete everything. So you need to know the basics, like, for example, if we're looking at the triangle here, sine of 30 degrees is 1/2 using the famous SOHCAHTOA here. All right, sine is opposite divided by hypotenuse. And I'm not going to write down all the values here, but you have to know how to use the triangles to your advantage. All right, so now the first thing what I suggest you do is to put the angles in degrees in first. So 0 degrees, 30, 45, 60, 90 degrees up top, or pi halves. Okay, plus 30 more is 120, 100, oops, that's multiples of 45, so that's going to be 135 degrees here. And then you add another 30 degrees, you get 150, and then 180 degrees, or pi radians. And you just keep going around that circle, okay? So add another 30, you get 210, and then you're at 225. That's a multiple of 45 right there, so 225 degrees. 210 plus 30 is 240. Okay, down here at 270 degrees, or 3 pi halves, 1.5 pi, 1 pi halfway around, plus another half of a half, so 3 halves pi. And then 270 plus 30 is 300, and then 315, and then 330 degrees, and then back to 360 degrees, or 2 pi revolutions, okay? 2 pi radians. Okay, now in radians, okay, switching colors, here we go. So pi divided by 6, 180 divided by 6 is 30. And then pi fourths. Okay, so actually I'm going to do multiples of 30 first. So pi 6, so 1 6, 2 6, which is the third. Okay, 2 6, 3 6, which is a half. 4 6, which is 2/3 of a pi. All right, that's 4 6. This is 5 6. 6 6, which is a pi, and then 7 6. Okay, and then 8 6, which is 4/3. And then 3 halves, okay, and that's 4 6. That's, let me see, what did I just say? 7 6, 8 6, 9 6, 10 6, which is 5/3. Excuse me. What did I just say? 7 6, 8 6, 9 6, 10 6, which is 5/3. So I'm going to fix this right here. That's 10 6, and then we have 11 6. Okay, so notice that when I get a fraction that can be reduced, then I reduce it. Okay, after you do that, then you put in your values. Okay, so here we go. So remember, it always goes cosine theta, comma sine theta. So x is the x coordinates cosine theta, the y coordinate sine theta. So you have to understand that. So cosine of 30 degrees is adjacent divided by hypotenuse, or rad 3 over 2. Sine of 30 degrees is 1/2. Okay, and then you have cosine of 45 degrees is root 2 over 2. And then sine of 45 degrees is the same thing, root 2 over 2. And then cosine of 60 degrees, well, that's 1/2. And then sine of 60 degrees is rad 3 over 2. So once you have your quadrant 1 reference angles, then you use symmetry, and you go to quadrants 2, 3, and 4. Okay, so for example, if I know 30 degrees, then if you go straight across, then you know all the values over here. They're the same, but the x-coordinate is negative. All right, so here this would be negative rad 3 over 2, comma 1/2, because you go left and up. So just using basic symmetry and know what the sign is. I know the cosine of 150 is negative because you're in quadrant 2 because you go left and up. But the y value is positive, so sine is positive. Okay, and then you do the same thing over here. You go straight across, okay? Oh, I forgot to do the radians for multiples of pi fourths. I forgot to do that. Okay, so here, let me do that first. Forgot. Okay, so multiples of pi fourths. So 1/4, 2/4, 3/4. So over here is 3/4 of a pi. And then you just keep adding, counting 5/4. So 1/4, 2/4, excuse me, that 3/4 here, 4/4, and that right here is 5/4. 6/4 at the bottom, and then 7/4. So you just count by fourths. So sorry about that, I forgot to do that. All right, so now back to the coordinates again. So you just go straight across, use symmetry. All right, so negative rad 2 over 2, and then rad 2 over 2. Symmetry, boom. Negative 1/2, and then root 3 over 2. And then now you reflect down. So if you go down, now both coordinates are negative. Okay, so negative rad 3 over 2, comma, negative 1/2, negative root 2 over 2, negative rad 2 over 2. And then again, you just go straight down. So up here at 2/3 pi or 120 degrees, you go straight down, and then it just change the signs. So negative 1/2, comma, negative rad 3 over 2. Okay, both are negative in quadrant 3. Both sine and cosine are negative in quadrant 3 because x and y are negative in quadrant 3. Then here, you just go straight down. From quadrant 1 to quadrant 4, you just go straight down. The x-coordinate is positive, but the y-coordinate is negative. So rad 3 over 2, comma, negative 1/2, negative rad, positive rad 2. Let me fix that. Positive rad 2 over 2, negative rad 2 over 2 at 7/4 pi, and then 1/2. Come on, Aynesworth. So 1/2, comma, negative rad 3 over 2. And then here, the coordinates of the position here, you're at 1, 0 because you're on the radius. You're in a circle where the radius is 1. Up here at 0, 1, at the very top at 90 degrees. At 180 degrees, you're negative 1, 0. And then down here at the bottom, you're 0, negative 1. Okay? And there we go. Now that's not going at my true speed because I'm talking here as I'm doing everything and I'm showing symmetry. If I was doing it by myself, it would take you half the amount of time. Okay, but that's it. That's what is that? Mastery number. That's mastery number 1 on the unit circle. This is Aynesworth. I'll see you in class. Bye bye.